In this video, I'm going to demonstrate how to create a Cosmos DB instance in Microsoft Azure. Now, Cosmos DB is a globally distributed NoSQL database with enormous scaling capability to handle very large data worldwide. Now, here I am in the Azure portal, and to get started, I'm just going to click Create a Resource. And in the new resource window, I'm just going to type Cosmos DB. And I get the option of Azure Cosmos DB. So I'll click that, and I'll click Create. Now I'm going to step you through the settings here one at a time, and we'll just talk about it a little bit. So the very first one, obviously, you need a subscription. So I have the single subscription that I have available here. You need a resource group, and I have an existing one, but you could click Create New if you don't have one. And I'll choose the resource group that I'm going to put my Cosmos DB in. Next, under Instance Details, I need to give it an account name. Now this has to be globally unique. So I'm going to call this Demo Cosmos DB, but there's probably one called that, and it tells me name is not available. That means that somebody else has used this name. So I'm just going to add some numbers at the end of it. And I get a little green check mark, so that means that it's unique. Next is API. Now Cosmos DB has several APIs to choose from. And this basically controls how your Cosmos DB works. So if you want to treat it like a SQL database, then you choose the Core or SQL API. There's also MongoDB and Cassandra if you want to treat them with the same interface as those databases. You can treat it as Azure Table, so you can treat it as table storage, or you can treat it as a graph using the Gremlin API. So I'm just going to leave it as SQL. I'm going to skip this one because we're not really talking about notebooks. Location is where physically in what data center do you want to install this. Now, I'm going to leave it at West US, but you could choose whatever region you'd like. Capacity mode is interesting. There's a preview type of mode called serverless. Now, first off, to explain, provision throughput means that for each container that you create in Cosmos DB, you specify a throughput, and that just defines how much traffic it can accept. And you get charged by that throughput per hour. Now with serverless, and this is new, you don't have to specify the throughput. Essentially, you can have more or less throughput and you'll get charged for whatever you use. Now that's useful if you don't know what your throughput is going to be, but we're going to use provision throughput. And the next one, I'm going to skip the apply free tier discount because that's not too important. Account type, production or non-production. This doesn't affect how the database works. It simply affects the interface that you see. So the production interface is designed for production management, and non-production is not. Geo-redundancy is, do you want this replicated in different regions? Now you can do this after the fact, which I'm going to show you today. So I'm going to leave it at disable. Multi-region writes is interesting. If you only write to your database from one region, then you don't really need this. But if you want users from different parts of the world writing to your database on a regular basis, you might want multi-region writes, which allows users to write to the database in different regions, and then that is replicated to the other regions. Now I'm just going to leave it at disable for now. So I'll click Next Networking. So the next thing you get to choose is your networking style. And you can have all networks, and this means that anybody can access your Cosmos DB account. Now, when you get into configuring the Cosmos DB account after it's created, you can actually limit it by IP address. But for now, this is just all networks. Everybody has access. If I click on Public Endpoint Selected Networks, then I can choose which virtual networks can access as Cosmos DB. Now, if you want to limit access to your Cosmos DB to authorized users, then you're probably going to want to put your resources in virtual networks and control it that way. So the final option is private endpoint. And if I click on private endpoint, now a private endpoint is just an endpoint in a virtual network that is not routable via the internet. So it's more secure than a public endpoint. So if you have private endpoints, you can add them here. Now I'm not going to add any right now, so I'm just going to leave this on all networks. And I'll click Next Backup Policy. So for the safety of your data, you're going to want to have it backed up, and you can choose a backup interval. We'll leave it at the default 240 minutes. Every 240 minutes is backed up. Backup retention is it keeps that for 8 hours. So you can set all this to your own preference. I'll click Next Encryption. Data in Cosmos DB is encrypted in transit, and it's also encrypted at rest, which means when it's stored, it's still encrypted. You can use your own customer managed key to encrypt, or you can just choose a service managed key, which is the easiest. I'm going to skip over tags because we're not going to really review those, and I'll click Next Review and Create. So validation is successful. It's going to create a new Cosmos DB in the West US for me. It's going to put it in my resource group. It's going to be a SQL type database, and we've disabled geo-redundancy and multi-region rights, but we'll look at that in a minute. So I'll hit Create and we'll wait for this to create. Okay, that's complete. So I'll click Go to Resource. And I want to show you some of the details here. Remember that we chose no replication. Well, if I go under Settings and I click Replicate Data Globally, I can choose exactly what regions I'm going to replicate my database in. Notice that we created it in West US. So if I hover West US, I see that. And on the right, under Configure Regions, it says Multi-Region Rights Disabled. I can turn on multi-region rights just by clicking Enable, and it tells me how much I'll be charged for that. I'll leave it off for now. I can also click different regions to replicate. So you see, I just clicked on Central US, and it has a little check mark. If I choose West Central US, so I can choose different regions in the world that I want to replicate to. And if I hit Save, it just automatically replicates the database for me. So in conclusion, I've shown you how to create a Cosmos DB instance in Microsoft Azure. And I touched on the options that you have available to you when creating a Cosmos DB instance. In this video, I'm going to show you how to create a Cosmos DB instance in the Azure portal using an Azure Resource Manager or ARM template. So I'm in the portal right now, and I'm going to go to the search box, and in the search box I'm going to type deploy. Now the services that come up when you search for deploy, one of them is called deploy a custom template. So I'm going to click on that, and I get a custom deployment window, and this allows me to create my own ARM template and run it. You'll notice there's some common templates for virtual machines, web apps, SQL database. We're going to create our own, so I'm going to click Build Your Own Template in the editor. Now this is the Edit Template window, and it allows you to create ARM templates. Now I'm going to copy a simple ARM template and just paste it in here, and I'm going to step you through it. In this demonstration, I'm not going to be showing you everything that you can do with ARM templates because they can get very complex. This is just going to be a simple example. So ARM templates have an array. This is JSON, by the way. This is a JSON object. And there's a property called resources on line 4, and it's an array. So this is the array of resources that I want this template to deploy. I've only got one. It starts on line 5, so you can see it has one object inside the array. And on line 6, I tell it the type. Microsoft has a unique type for everything you can deploy. So the one for Cosmos DB is Microsoft.DocumentDB/database accounts. It's also case sensitive, just so you're aware. On line 7, we have an API version. Now there are different versions of the API that will run to deploy this resource. And you can look online in the Microsoft documentation to find out what API version you can use here. But this is for backwards compatibility. So you see my API version is the one that's come out in 2020, and it's June the 1st, and it's a preview. On line 8, I just give it a name, and I have to give it a globally unique name, so I call it Demo Cosmos ARM 266. The 266 is just to make it unique. On line 9, I tell it the location. This is the region where it's going to install my Cosmos DB instance. Now I use some script here to put it in the location of the current resource group. But I could put a resource group name here. Under Properties on line 10, I have some details about my database. Line 11 is a database account offer type, and that is standard. On line 12, consistency policy, and this is on line 13, the default consistency level is session. Again, you can look at Microsoft documentation to see what the options are here. On line 15, is the locations, and this is another array. And what this is if you want multi-region, these are the locations for the multi-region. On line 17, I just have one. A location name is the location of the resource group. So it's only going to be single region, and it's going to be in the resource group's location. So that's all there is to this. Again, this can get a lot more complicated, and just about anything that you can do with Cosmos DB, you can configure in here. But we're just going to use this simple one as an example. So if I click Save, it now stores that custom deployment, and I can review and create it. So I have to fill in a subscription, and it's already got my subscription filled in. Resource group, you can click Create New if you'd like to create a new one. I already have one existing, so I'm going to choose it. Notice it locks in my region. That's my location. It's East US. I can't change that because that's the region of the resource group. I'll click Review and Create. And validation is passed. So now it has the terms, and I can click Create. So this is using the same backend that Microsoft Azure uses to create any resources when you just decide to click Create a Resource. The only difference is that you can write your own template. So that's deploying, and we'll just wait for that to complete. Okay, so that's finished, and if I click Go to Resource, it'll take me to my new resource. So you see I have an Azure Cosmos DB account. It's called demo-cosmos-arm-266. And if I take a look at Replicate Data Globally under the settings on the left, remember that I told it to deploy this in the location that the resource group is in, and I made it a single region, and here it is, East US. So that's actually the region in which my resource group is in. If I go back to resource groups, and I open up my resource group, you will see in the overview that it's in East US. So in conclusion, I've shown you how to create a Cosmos DB instance in the portal using an ARM template. There are many different ways you can run an ARM template. You can use PowerShell or Azure CLI. There are also project templates in Visual Studio that allow you to run them. ARM templates are extremely flexible, and they're well documented online by Microsoft. In fact, Microsoft uses ARM templates under the hood whenever you create a new resource. In this video, I'm going to show you how to create a Cosmos DB instance in Azure using only PowerShell. So I'm in the Azure portal, and just to the right of the search box is a button for the Azure Cloud Shell. So I'm going to click that. And the first thing I need to do is create storage, because Azure Cloud Shell requires a storage mounted. So I choose my subscription, which in this case is free trial. I hit Create Storage, and it immediately tells me there's an issue. And if you see this, what's likely the problem is that you have to click Show Advanced Settings and set up names for your storage account. So I have a resource group set up. You could create a new one if you need. And then you have to give the storage account and file share a name. Now I'm just going to use a random name of test and some numbers. And you can use the same one for the file share. And click Create Storage. Now that's going to take a few seconds. I'm going to pause and we'll just wait for that to finish. Okay, so that's finished. And what's happening now is that Azure is connecting me to the terminal. Wait for a few seconds. Okay, and we're connected. So I'm authenticated because I'm logged in to the Azure portal. Now the first thing I'm going to do is I'm going to run an install module. The problem here is that we need Cosmos DB to be installed. So I'm going to run install module az.cosmosdb. Now you will be asked, if you do this yourself, if you want to install the modules from PS Gallery. I just do a capital A for yes to all and click Enter. Okay, now that's complete. So I can type CLS to clear the screen. So now I'm going to enter some PowerShell script. So let me show you first what the PowerShell script looks like. Here it is. And let me step you through it from lines 1 to 4. What I'm doing is I'm setting up a locations variable in PowerScript. It's essentially a series of 3 commands, and the commands are new-az cosmos_db location object. So I'm creating an object that has 3 objects in it, and they have properties of location name, failover priority, and is zone redundant. Now I'll just talk you through a few of these. Is zone redundant is not very important right now, but location name is important. These are the locations that the multi-region is going to be set to. So East US, so that's the first failover priority. This is going to be the write location and the read location. It will also be the location where the instance is installed. There are other regions it will use for replication. West US will be the second one with a failover priority of 1, and Canada Central with a failover priority of 2. So we will attempt first to read from East US if there's a read request. If that fails, it will fail over to West US, then finally it'll fail over to Canada Central. So it'll go in the order of the failover priority. The next line is the actual command that creates the instance. It's new-az cosmos_db account. And it has a resource group name, and this is my resource group. Location object on line 8 is the locations that we've just set up. Line 9 is the name, and it has to be a globally unique name. So actually I'm going to modify this just slightly and call it demo-cosmos-ps-267. Line 10, API kind. Now this can be SQL, this can be a gremlin graph, this can be a table type. We're just going to go with SQL. On line 11, enable automatic failover is true. And on line 12, default consistency level is session. Now you can look up documentation to know what the consistency levels are. Now these are by far not the only arguments that you can set on this call. You can check the Microsoft documentation for what arguments are available. This is just a simple example. So I'm going to copy this, and then I'm going to paste it into the PowerShell window that we have. Now what it's doing is it's setting up the locations. Now as soon as I hit return, it's going to run the new AZ cosmos_db account statement. So it's running that right now. I'm just going to pause it until it's complete. Okay, so that's just finished. And if I scroll up here, you can see the output is a whole bunch of information about my database. So if I just close this PowerShell window and I go to my resource groups, I have some other things set up, but you see the demo Cosmos PS267 Cosmos account. If I click on that, this is what we've just set up. And if I go to replicate data globally under settings on the left, you'll be able to see the result of what we set on locations. The write region, and it's also a read region, is East US, and we can see it listed here if I go on the map. And the additional read regions are West US and Canada Central. So in conclusion, I've shown you how to create a Cosmos DB instance in Azure using only PowerShell. Now I use the PowerShell feature of Azure Cloud Shell. You can also install PowerShell on your local machine and run it against Azure in the same manner. The only real difference is that you would have to log into your Azure account. In this video, I'm going to show you how to create an instance of Cosmos DB using only Azure CLI script. So in the portal, just to the right of the search box, there's a button, and if you click on it, it'll take you to the Cloud Shell. You can see it at the bottom of my screen. I'll just make that a little bigger. Now, if this is the first time you've ever used the Azure Cloud Shell, it will prompt you to create a storage account. So just go through that and create the storage account. I already have one, so it just logs me in. Now to do CLI, I have to switch something. At the top left, where it says PowerShell and it's a pull down, you have to choose Bash. And it'll ask me to confirm to switch to Bash, and I'll hit confirm. So that reconnects me, so now I'm in Bash. Now I can do CLI statements. So I'm going to copy the statement that creates a new Cosmos DB instance, and I'm just going to paste it here, and we'll step through it. So the command starts with AZ, Cosmos DB create. The first argument is a name or -n, and it's the name of my instance. Now this has to be globally unique, so I've just chosen demo cosmos CLI 436. The number just makes it a unique name. On the next line, I have the resource group. So this is my resource group that I'm placing it in that already exists. I'm setting on the next line the default consistency level, and you can look on Microsoft documentation as to the valid values are here, but we're just going to set it to session. Now the next 3 lines set up locations for our database. These are regions, and you'll notice there's 3 regions. The first one is West US 2, the next is East US 2, and the final one is Canada Central. They each have a failover priority. Failover priority 0 is the one that's going to be the default region. It's going to be both read and write. It's going to be in West US 2, and that's where our database is actually installed. The subsequent failover priorities are the ones that it's going to fail over if that one fails. So if West US 2 fails, it's going to first try to fail over to East US 2 because that's next in the numeric list of failover priorities. Then it will fail over to Canada Central if East US 2 fails. So this one line is going to create our Cosmos DB instance. So I'm just going to hit enter. Now this may take a while, so I'm just going to pause and we'll wait for it to finish. Okay, that's just completed. So now you can see that the result is a large output. Essentially, it's a JSON object that describes what has just been created. If we look through this, we can find locations. Here it is right here. Here's the locations array, and it shows West US 2, and provisioning state is succeeded. East US 2 succeeded. Canada Central succeeded. So it succeeded in deploying that to those 3 different regions. Now let's just go to the portal for a minute. So I've closed the Cloud Shell, and I'm going to go to my resource groups and open up my resource group, and let's take a look at what we've created. So there's a few in here, but the one we just created was Demo Cosmos CLI 436. If I click on that, and if we go to replicate data globally, you'll be able to see the different regions we've deployed in. Our main region, which is a lighter blue, is West US 2, and on the right you can see it's a write region. By default, it's also a read region. The other 2 are Canada Central and East US 2 that are a darker blue. And you can see they're listed under additional read regions. So in conclusion, I've just shown you how to create an instance of Cosmos DB using Azure CLI script. Azure CLI script will allow you to manage your instance completely. So for example, you could also reconfigure your instance using Azure CLI script. So you could run another script and change which regions are deployed. Now I've just shown running Azure CLI in the Azure Cloud Shell, but you have a lot of options too for running CLI script. You can download tools that allow you to run CLI script from the command line, and you can also install it in Visual Studio so that you can run Azure CLI script directly from Visual Studio. In this video, I'm going to demonstrate the firewall settings for Cosmos DB. So I'm in the Azure portal, and I have, as you can see under my recent resources, an Azure Cosmos DB account. I'm going to open up that account, and I'm going to show you the firewall and virtual network settings that are under settings on the left. If I open that up, there are 3 main ways that you can set up this firewall. The first one is to allow access from all networks. Now if I click this, notice it says all networks, including the internet, can access this Azure Cosmos DB account. So this means that absolutely everybody can access the account. It's like not having a firewall. Now I'm not going to hit save on that. That is the easiest way to set up a Cosmos DB account because it allows you to test on it and nobody's locked out. The problem is it's like having no firewall. Now the next one is to choose selected networks, and in this way you can control who has access. The first way you can do this that I'll talk about is individual IP ranges. So you can add IP addresses in here, or you can use CIDR ranges. But regardless, what you're doing is you're specifying IP ranges. Now, right now it has none at all. So that means that the way it's set up now, nobody would be able to access it, other than actually the Azure portal, because under exceptions at the bottom, I have checked by default, allow access from Azure portal. And what this means is that the IP ranges for Azure portal are open on the firewall, and that's all that's open. So I would be able to use this interface, use all the settings on the left, and access my database. But otherwise, there's no access. So if I had, say, a service on Azure and it wanted to use this database, it wouldn't be able to access it. I would need to put that service's IP address in this list here of IP addresses. Now, there's some downsides to using IP addresses for the firewall, and that's that it doesn't automatically add new resources. You'd have to come in here and add their IP addresses. The second thing is that the IP addresses have to be static. Now, some resources in Azure and other services have static IP addresses, but some don't. Some are dynamic and the IP addresses change. So you wouldn't be able to set those up in here using an IP address. Now, a third way is through virtual networks. A virtual network is good because you don't have to specify IP addresses. Now, I'm not going to create a new virtual network because this demo is not about virtual networks per se, but you can create a virtual network, and what that allows you to do is add Azure resources such as other services, applications to that virtual network, and then you can give it access here. You can either add an existing one or create a new one. So you can have a whole list of virtual networks that your firewall allows access to. That gives access to all the resources in those virtual networks. So that means when you have a new resource, say a new service comes online, and you want it to be able to access this database, well, you can just add it to a virtual network that already exists that's in this list, and then it'll automatically have that access. So those are the three ways. Now, what I want to do is I want to show you an actual example of this firewall working. So what I'm going to do is I'm going to go to Data Explorer on the left. And first I want to note that right now, the way I have the firewall set up, there are no IP ranges set up and there are no virtual networks. So I should not be able to access the data in my database. So if I click on Data Explorer on the left, I do have a database set up. I actually have two. I have some test databases. I'll open up one under Test2. It has a Test2 container under the database. And I'll click on Items. Now this has no items, so I'm going to click New Item at the top. And I'm just going to default this. I'm going to let it create this item with this ID. I'm going to hit Save. Now here's the message that you get. Request originated from client IP, and this is the IP address of my Cosmos instance, through the public internet. This is blocked by your Cosmos DB account firewall settings. So I currently, even through the Cosmos DB instance itself, I cannot modify the data. So if I go back to my firewall settings, what should I do about this? I could turn on all networks, because that will allow everything. But what I'm going to do instead is under Firewall, I'm going to click Add my current IP. And you should note that the IP address 24.114.89.25 is the one that it was complaining about. So if I click Save, that will allow access through the firewall, at least of my Cosmos DB instance itself. Okay, so that's been saved. I'm going to go to Data Explorer. Now I'm going to go back to my Test2 database and my Test2 container and click Items. Now I should be able to create the item, but I will show you something. If I click New Item and I hit Save, I'm still getting the same error. Now why am I getting that if I've given the IP address 24.114.89.25 explicit access? Well, the reason is because there's a delay when these changes propagate for the firewall. So I'm just going to pause here and wait. It can take several minutes. Okay, so we've waited several minutes. So now I'm going to click Save. And you see that it now saves my new item. And it's now in the database. So let's go back to Firewall for a second. So I've shown you how adding the IP address to the firewall actually allows access. I'm just going to talk for a second about the exceptions at the bottom. These can be useful in some cases. The first one is accept connections from within public Azure data centers. Enable access from Azure IP range when you have interaction with another service. The problem with checking this is that it gives access to all public Azure data centers. So that means other subscriptions can potentially access it. So it's kind of widespread to turn this on, so it's not always a great idea. It's better to use more restrictive methods. The other one is allow access from Azure Portal. So as it states, this basically opens up the range of IP addresses that the portal uses. So this interface, if we turn this off, we won't be able to access the database at all via this portal interface. And it actually warns you. Without portal access enabled, you'll not be able to perform any operations within this account from the portal. Now that's great if you're programmatically accessing it, but you definitely don't want to save that if that's not what you want. So in conclusion, we've just looked at the firewall settings for Cosmos DB. Now there are basically three ways to set up your firewall. You can allow all networks, which is essentially no firewall. And this is the least secure since anyone, including anyone on the internet, can access your Cosmos DB. Secondly, you can list specific IP addresses of resources that are allowed access. Now this is only useful if the resources have static IP addresses. Some resources have dynamic IP addresses. And finally, you can choose selected virtual networks. In this way, you can organize the resources that you want to allow access to your Cosmos DB to specific virtual networks. And if you want future resources to have access, you can add them to those virtual networks and they'll inherit the access. In this video, I'm going to demonstrate the ways that you can authenticate with Cosmos DB. First, we're going to look at using an authorization key, and I'll show you authenticating programmatically via a Visual Studio project using an authorization key, and setting up a database and a container. Then we're going to look at using Cosmos DB users on a database for more fine-grained access control. While it's out of the scope of this demo to access the database as these users via what's called a resource token, I will demonstrate how to programmatically create a Cosmos DB user on a database and assign that user permissions, and we'll discuss the ramifications of doing so. So I'm going to start off here in Azure Portal, and the first thing I'm going to do is go to my Azure Cosmos DB account. And what I want to do is go to Data Explorer on the left, and I want to show you that the database is empty. We have no containers and no databases. We're going to create those programmatically. So I'm going to go to Visual Studio, and I'm going to show you how that works. So I have a program here, and starting on line 10, I have two constant strings, an endpoint URL and an authorization key. Now those are the only two pieces of information you need in order to access the database with an authorization key. So this is not a very secure way of accessing, because anybody who has the key and the endpoint can access everything. But it is the easiest way to start. So I'm going to grab those two pieces of information. You can get them from your Cosmos DB account in Azure. So I'm going to go back to Azure, and I'm going to go to the overview on the left of my Cosmos account. And first of all, the URI is on overview, and I can just copy it to the clipboard. And if I go back to my code, that's the endpoint URL on line 10. So I'll paste that in. Now if I go back to Azure, on the left under settings, I'll go to keys. Now there's two types of authorization key. There's read-write keys, so that gives full access. And then there's read-only keys, so that will only allow you to read the data. We're going to take a read-write key, since we're going to be doing some administrative database and container creation. And there's a primary and a secondary key. It doesn't matter which one you take. They'll both work, but I'll take the primary key. Back to code. And on line 11 for authorization key, I'm going to paste that in. Now this is a secret, and obviously in production code you would not have a secret in your code. But this is just for demo purposes. On line 14, I actually connect to the Cosmos client. So that's connecting to my Cosmos instance using the URL and the authorization key. I will note that I am using a specific NuGet package. So if I go to Solution Explorer and I right-click on my project and choose Manage NuGet Packages, you'll see that I'm using the Microsoft.Azure.Cosmos NuGet package. So that's required for this. On line 14, once I have the client, I then call a create database, and I give it the name DemoDB. On line 16, I just get that database back from the client now that it's created. On line 17, I create a container inside that database, and I give it the name demo container, and I also have to give it partition properties. So that's the path /p. P is the name of the property I'm giving for the partition. A partition is important. We won't go into partition in great detail here, other than to say that as we go on here, you'll see that I can give permissions to users to particular partitions. And it's just a property on the records that are in the database. So there will be a property on every record called P, and that is a partition. On line 18, I get that container that I've created, demo container. So I'm going to comment out the rest of the code for now, and we'll just run this. So I'll hit F5. Okay, so that's run successfully. So now if I go back to Azure, so I just want to prove that with those two pieces of information, the authorization key and the URL, I was able to access my account and create a database in a container. So if I go to Data Explorer on the left, so now this isn't empty. It's got a database called DemoDB, and if I expand that, I see my demo container. Now if I go back to my code, we're now going to comment out what we've already run, and I'm going to uncomment what starts on line 21. I actually have to uncomment the line that gets the database. So that's on line 16. And also line 14, which creates my client. So I create my client, get the database. On line 22, I'm going to create a user. Now the idea here is that Cosmos DB users are a way of having more fine-grained control over what users can access what data. These are not Azure users or Azure groups or anything like that. These are specific to Cosmos DB. Now with an authorization key, it gives full access to anybody who has the authorization key, or read-only access, depending on the key type. In this case, we want to give specific users, when they log in, specific rights. So on line 22, I'm creating a user called user1. On line 24, I'm creating a permission. This permission specifies, on line 26, it's called permission user1 test. That's just a unique name for it. Line 27 is a permission mode. I'm giving only read. There's two options here. It's either read or all. All gives full ability to read, insert, replace, and delete. But I'm just going to give read to this user. On line 28, I have to specify the container. And I realize that I need to get the container on line 18. And on line 29, I specify the partition value of the partition key. Remember, the partition is a property called P. So this user would only have read access on the container that we created called demo container, and they would only be able to read the records that have a property P with the value 0, 1, 2, 3, 4, 5. So they can only read that partition or that subset of records. So this is how you give fine-grained control of permissions of records. Now it's beyond the scope of this demo to actually show how the user would log in and access those records. They'd use something called a resource token. But what I will show is creating the user. So I will run this code right now. F5. And it's come back with a code 0, so it's created the user. Now, unfortunately, there's no UI in the Azure portal to show the users. So we won't be able to see anything as a result from this, but this creates a permission for a specific user. So in conclusion, there are two ways to authenticate with Cosmos DB databases. The first is an authorization key, which is the easiest and the least secure way. Any identity with the key is given either full read-write or only read access to all the data, depending on the key type you give. Secondly, you can define Cosmos DB users on Cosmos DB database objects, and assign them permissions to the data in specific partitions of specific containers. In this video, we're going to look at the security features of Azure Cosmos DB. Security is always high importance for cloud-based distributed systems, and it's particularly sensitive for a highly distributed and scalable database like Cosmos DB, which stores a lot of sensitive information for organizations worldwide. Encryption is a security feature which encodes data so only authorized people can read it. It's common to encrypt data while in transit on a network. This is how the HTTPS protocol works. But often, once data is at its destination, it's decrypted before being saved. In this decrypted state, the data is readable by anyone who might gain access to it, even those who are unauthorized. Cosmos DB encrypts data at rest as well as in transit, meaning that the data stored in the database is encrypted at all times, so it's not readable unless someone is authorized via a valid key or certificate. This makes the system more secure even if the database were somehow compromised. There are many dimensions to database security because there are many types of people who may try to access the data in your database and may compromise it. System administrators typically have elevated permissions to the database and therefore could compromise the data if they were malicious. Depending on the nature of the data, some systems inherently trust that administrators will not be malicious, while in some systems, where the possibility of maliciousness is likely, such as banking systems, the security stance is to assume administrators could be malicious. Of course, you need to assume that some customers may want to inappropriately access the data, and therefore system security must be tight to only allow authenticated and authorized users access. Customers should have minimum authority, meaning no more authority than they absolutely need. If a user only needs to read a single report, they should only have access to that report, and their authorization should be limited to read only. The database provider must also be considered, as they'll have direct access to the database. So security measures should consider limiting access to database providers as well. Your security stance for your database is going to be different if you host your own database than if you go with a third-party provider such as Microsoft Azure. If you host it yourself, you'll be your own database provider, and the administrators will work for you. You'll be responsible for limiting their access. With a cloud provider such as Azure, they're the database provider, and the administrators work for them. In that case, your database is a platform as a service, and will come with security agreements from Microsoft, which makes your security job much easier. Now let's look at some best practices for keeping your database safe. If you host your own database, these will be your responsibility. But if you use a platform as a service like Azure's Cosmos DB, these should be handled by your platform provider, although you may still have to ensure that your database is configured appropriately. There are constant security updates to software these days, so make sure you always have the latest updates and patches. With Cosmos DB, this will be automatically handled for you. Any URLs that your solution exposes should always be HTTPS, which is encrypted traffic, rather than just HTTP, which is not encrypted. And strong passwords are a must. Your system should enforce strong passwords. Azure not only enforces strong passwords, but also has other advanced security measures such as multi-factor authentication. Assuming that you're choosing Azure Cosmos DB as your hosted database solution, let's look at some of the security measures that affords you. Cosmos DB has security at the network level in the form of a firewall that only allows authorized IP addresses access to your database. Cosmos DB supports Active Directory integration in the form of Azure Resource-Based Access Control, or RBAC. This means that you can control what permissions Azure users have to your databases in the form of roles. Microsoft promises high availability through their service level agreement on Cosmos DB by using local replication under the hood. Cosmos DB databases are automatically backed up on a regular schedule, and these backups are replicated across regions to avoid data loss. Cosmos DB stores data in containers that are isolated, so you can store your sensitive data in their own containers and control authorization at the container level. Cosmos DB can secure your data via certificate and also via an access key. While managing security with certificates is more secure, using an access key is easier and allows you to get started quickly when you're first learning Cosmos DB. Therefore, let's take a look at how access keys work with Cosmos DB. Access keys are used throughout Azure, not just in Cosmos DB, to secure access to resources. They're basically keys auto-generated by Azure, so only those who have the key are granted access. They're created on Cosmos DB during the creation of the database, and two access keys are automatically generated, a primary key and a secondary key. There are two keys to support key regeneration, which means generating a new key. You can press a button in Azure and regenerate the key that's not being used by your clients. This replaces the old key in that slot. Then you would communicate the new key so your clients switch to it, and next time you regenerate the key in the slot your clients are no longer using. By swapping back and forth between two keys for key generation, you can never disrupt your clients by invalidating their key. And you should regenerate keys on a regular basis. Note that access keys don't offer granular access. They either grant or deny access to the entire Cosmos DB instance. You can use Azure's role-based access controller, RBAC, if you need to assign finer control to an entity on the database, such as full control versus read-only. And finally, there are resource tokens that can be generated to give permissions to subsets of data in your database. In this video, I'm going to demonstrate the Cosmos DB Data Explorer. I'll use the Data Explorer to create a new database and container, populate that container with data, and then query the data. So I'm starting off here in Azure portal, and I'm going to go to my Azure Cosmos DB account under Recent Resources. And in my account on the left, there's an option for Data Explorer. So I'm going to click that. And that takes me to this UI that allows me to basically query my data and manage my data. Now, one note about Data Explorer is that it's not a very advanced editor. It's really just a get started type of Explorer that Microsoft has put out to allow you to take a look at your data right away without any extra tools. If you're doing any serious database management, you're probably going to be using a more serious tool. Well, let's just step through this tool. So the first thing I'm going to do is up in the top left, there's a new container button. And I'll just pull down the menu here. There's a new container and a new database. Now in Cosmos DB, databases are the topmost layer and containers exist inside databases. But if I click new container, I can create both at the same time. So I'm just going to click new container. And on the right, I have the add container window. And because I don't have a database to put my container in, I have to create a new database. So I have to give it an ID, which is just the name. So I'm just going to call it DemoDB. And you see that you provision throughput on your database. The throughput is how much data flow it can manage. And I'm just going to leave it at the default of 400 request units per second. Now, if I scroll down, I have to name the container. So I'm going to call that persons. A couple of options here. Indexing is automatic. This means that it'll index every field of every record. So that's very useful if you're doing a lot of querying. If you're only doing simple querying off of one key or no querying at all, then you can turn indexing off. You need to add a partition key, and this is basically one of the fields in your records. So I'm going to say it's my name. I'm going to have a name field. And it's a path, so I go /name. And we'll leave the rest as it is, and I'll hit OK. Okay, so now it's created my container in my database. So on the left, under SQL API, you see DemoDB, which is my database. And if I expand it, you see persons, which is my container. So what I'm going to do is I'm going to put some data in this container. So I'm going to click Items, And at the top, I'm going to click New Item. And I'm just going to cut and paste some new items. So my first new item is going to be, this is a person. Name, John Doe. On line 2, line 3 is age, 45. Line 4 is hobbies, are car restoration and skiing. So a few things to note here is these properties can be of different types. On line 2, name is a string. On line 3, age is a number. And they can even be more complex. You can have nested objects, or you can even have arrays like I do on line 4. Now, this is NoSQL. NoSQL is a lot more flexible in what can go into a record than SQL. If you're using something like SQL Server, then the table would be defined and each record would have exactly the same properties. In this case, I can have different properties in each record. This represents a record, and I'm going to put more records in. And you can also have things that you can't have in a SQL database, such as arrays and embedded objects. So I'm going to click Save at the top, and that saves my object. A few things, if you take a look at the object on the right, you'll see the properties I've added, and you'll also see some extra properties. On line 8 is ID. It automatically adds a unique ID to your record. And if you don't specify an ID, it'll just create one, and it'll look like a GUID. But if you want to specify your ID, you can. And then all of these that have underscores are properties that are created automatically by Cosmos DB, and they're used by Cosmos DB. So let's add a new item. I'm going to click New Item at the top and create another person. Ruth Bitterman, age 65, 123 Easy Street. So Ruth has a field that's different from the other record, address on line 4. Also notice she doesn't have any hobbies field. I'll click Save, and that creates Ruth Bitterman. Now I'll click New Item one more time, and we'll create a third person, Alice Nelson. Alice Nelson has an address, 123 Easy Street, and hobbies, but no age. So I'll click Save. So now I have 3 records in my database. So what I'm going to do now is I'm going to show how you can filter this list using a query. So at the top it says Edit Filter. I'll click that button. And notice that this is an extension of a query. On the left it says Select star from C. So C represents my container. And I can type a where statement here or any other type of statement that could follow that. So I could say where C dot age is less than 50. I'll click Apply Filter on the right. So it filters the list down to John Doe. If I open up John Doe is 45. He's the only one who's under 50. Remember that one of our people does not have an age, so they would be filtered out in this sort of list. If I click Edit Filter again, another thing I can do is I can actually filter by the array as well. So here's a where statement that looks in the array. So here's a statement that looks in the hobbies array. Where array underscore contains, and in round brackets, c.hobbies, comma, and then in double quotes, skydiving. So I hit Apply Filter. This shows me all of the people who are into skydiving, and it's just Alice Nelson. Let's see who's into skiing. And there's 2 people who are into skiing, John Doe and Alice Nelson. So that's just some basics on how you can query your data and how you can place data directly into Data Explorer. Now let me step through some of the options at the top just so you're familiar with these. You can also upload items from a file. You can obviously delete or discard items. You can update your items. Some other options here is you can create new stored procedure. You can also create a new user-defined function, which is similar. And if I pull down that menu again, there's a new trigger option. So I can create a new trigger, and it has trigger type and trigger operation. So I can choose pre or post for trigger type, and operation is create, delete, replace, or all. So what this means, for instance, if I choose create on the trigger operation, and I leave trigger type as pre, it means that it'll run this function before every create of a record on this container. I can say post and all, and that means that it will run this trigger after every operation. Create, delete, or replace. So some other options here are a new SQL query up in the top options. And if I click that, I get a free form query editor. So I can run different types of queries that are a little more complex than the filter query I showed you. There is the option also of adding Azure Synapse. So you can link to Azure Synapse, and what that allows you to do is do complex analysis. So in conclusion, I've just shown you how to access Data Explorer for Cosmos DB in the Azure portal. And this is just one of the ways that you can interact with your databases and their contents. In this video, we're going to look at the global reliability and low latency that today's distributed databases can offer. And we'll discuss some details of how that's possible in a distributed system. We'll be focusing on Azure Cosmos DB, but many of these concepts also apply to other distributed databases, such as MongoDB or Cassandra. One big challenge for distributed cloud databases is that they have potential clients across the globe, and they need to guarantee the same low latency in Australia as they do in the UK or Japan. Given unpredictable network latency over long distances, this is virtually impossible if the database is physically situated in one place. Therefore, cloud platforms distribute replicas of the database across multiple regions in the world, and read and write requests are forwarded to the replica that's closest to the client. This way, Australian clients are served from a database instance in Australia, and Japanese clients are served from a database instance in Japan. From the client's perspective, this can look like a single global data instance and maintain low latency everywhere. Using Cosmos DB as an example, it guarantees that read and write requests can be handled worldwide from the multiple regions that Azure offers. As mentioned, the reads are done by having replicas of the database in supported regions. The writes are handled by replicating writes to various regions and by relying on eventual consistency, meaning that writes may not be reflected in all regions simultaneously, but all replicas will be consistent after a certain period of time. It's important to note that the client calls Azure Cosmos DB's multi-homing APIs to make the reads and writes, so the multiple regions are opaque from the client's perspective. The multi-homing APIs determine which region to send the request to based on the client's location information. Using this multi-region approach, Cosmos DB offers an impressive 99.999% read and write availability worldwide. It also guarantees low latency. About 99% of read and write calls will return a result within 10 milliseconds. Another feature of Cosmos DB is that it offers unlimited elastic read-write scalability, so it grows and shrinks with your data needs. You can add regions if required to cover new territory. All of this comes with no downtime. Because of the distributed nature of the database, it can continue to offer the same availability and latency guarantees while it scales. Business continuity is of utmost importance to all businesses. You don't want your business to be negatively affected if a database goes down. To facilitate business continuity, Cosmos DB supports automatic failover. This means that if a regional replica of the database fails, requests will automatically be intelligently routed to other nearby regions. Your customers should experience no effects. Cosmos DB maintains the same guarantees it always does: latency, availability, consistency, and throughput. One ironic downside of this automatic failover is that it makes your business's continuity preparedness more difficult to test. Your systems should be built to be ready should there be no access to Cosmos DB. But on the other hand, due to its automatic failover, Cosmos DB will almost always be up. Note that there's an implicit reality here that no database can ever guarantee 100% uptime. So there is a slim chance that your Cosmos DB instance may fail and the automatic failover doesn't save the situation. So how do you test that preparedness? Well, Cosmos DB has a special API that allows you to simulate a manual failover to test your systems. Some other considerations for Cosmos DB are scalability. Cosmos DB can scale elastically across all regions you choose, and it can write to any region, replicating the writes across all regions. Cosmos DB stores data in containers, which let you choose a guaranteed throughput, which Cosmos DB measures in resource units per second, or RUs per second. An RU is a standardized measure of resources used to perform an action on the database, and different read and write requests will represent a different number of RUs. But basically, you can set the total number of RUs, or how many standardized requests can be performed per second on the container, and that applies across all regions. Cosmos DB performs some intelligent indexing and partitioning behind the scenes to ensure this. Cosmos DB also offers a range of consistency models. Consistency, or how quickly a write to the database is reflected in subsequent reads, is a trade-off in a distributed database like Cosmos DB for performance. These models allow you to fine-tune that trade-off and choose whether consistency or performance is more important to your application. This global reliability that Cosmos DB affords will extend to the applications that you build on top of Cosmos DB, and your clients will experience the near real-time reads and writes as a more responsive application, no matter where in the world they're using your website. So to summarize, Cosmos DB offers high availability by running replicas of your database in multiple regions and distributing changes across all replicas. This ability to have high availability comes with a compromise of eventual consistency, meaning there's a potential delay between a write occurring in one region and when it's replicated across all regions. This is a compromise that's configurable in Cosmos DB as consistency models, since different applications require different levels of consistency. This results in Azure Cosmos DB being able to offer 99.999% read and write availability across the globe for multi-region databases. One of the ironic realities about globally distributed cloud databases such as Cosmos DB is that you don't necessarily want the entire globe to access them. Most of the time, you want to block unnecessary requests, strictly limiting access to your database to a small number of IP addresses. Imagine you've created an application that uses a multi-region Cosmos DB instance as its backing database. You would probably only want your application services accessing that database. You certainly wouldn't want to allow traffic from any random IP address on the internet. In this video, we're going to look at how Cosmos DB blocks unwanted requests. We're going to look at it from a logging point of view, as well as from an SDK point of view when you're writing an application that interacts with the database. And finally, we'll discuss what this means in a virtual network. Cosmos DB has a built-in firewall that allows configuration of what ranges of static IP addresses are allowed to access your Cosmos DB. Requests originating from outside those ranges will be rejected. This gives you granularity right down to the machine of who can access your database. If you only want internal access via other services or resources in Azure, then add those IP addresses to the ranges. Some Azure internal resources don't have static IP addresses, and in this case, there is an option in the configuration of Cosmos DB to allow all internal Azure IP addresses. Unfortunately, this opens wide ranges of IP addresses, including those from other subscriptions in Azure. Therefore, use static IP limitations instead if possible. If you have diagnostic logging enabled, request attempts and the corresponding responses will show up as log messages. You'll see these in the log as 403 error codes, meaning forbidden. The message should include the source IP address that was blocked. This can be useful to determine what invalid IP addresses are attempting to access your database. It may expose a malicious client, for instance. Logs are great for developers and administrators to determine who's trying to access your Cosmos DB account. But you also have to consider how your applications are going to interact with Cosmos DB. Most developers use Microsoft's Cosmos DB SDK in their code, and that SDK will return a generic 403 forbidden response if the IP address being used is denied by the database firewall. The response won't have any more information. So if your applications are getting 403 return codes when attempting to access your Cosmos DB database, make sure that the application's IP address or addresses are included in the ranges of acceptable IP addresses on your database configuration. You can also place resources that require access to your database in one or more subnets within a virtual network. Then, instead of listing public IP address ranges that are allowed access, you can instead choose in Cosmos DB configuration to allow only selected virtual networks access. You can then create an access control list of subnets, explicitly allowing access only to those listed subnets. This is a more efficient way of controlling access without having to specify literal static IP address ranges. Cosmos DB also has support for private IP addresses in an Azure virtual network. This is an even more secure method than using public IP addresses, because private IP addresses are not routable via the internet, so have less of a security risk footprint. Cosmos DB has a feature called Private Link, which is separate from the main firewall configuration and allows you to limit access to private IP addresses. Note that you cannot list private IP addresses in the firewall configuration in Cosmos DB. You need to use the private endpoint connections configuration. Make sure that you don't list any private IP addresses in the firewall configuration as allowed addresses, because this will not work. So to summarize, here are the ways in which you can limit access to Cosmos DB by IP address. You can configure the firewall to only allow given ranges of public IP addresses. This is only useful if your clients have static IP addresses. You won't be able to give access to a client with a dynamic IP address in this fashion. You can also set up a virtual network with subnets and limit Cosmos DB to only allow requests for an access control list of subnets. This is often preferable to listing literal IP addresses, since you can add new resources to that subnet, and that resource will automatically gain access regardless of its IP address. And finally, you can limit access to private IP addresses in a virtual network. Private IP addresses are more secure than public ones because they're not routable via the internet, but are instead limited to the subnet that they're in. Any way that you limit access via IP address, note that this is just one layer of access control in addition to the other forms offered by Cosmos DB, such as Resource-Based Access Control or RBAC and resource tokens. When you include Cosmos DB as a managed resource in your architecture, you must educate yourself and your team as to how to diagnose problems around interfacing with Cosmos DB once your code is in production. The good news is that Cosmos DB, its SDKs, and Azure itself offer many ways to diagnose networking issues. In this video, we're going to look at best practices when diagnosing networking issues, particularly when using Azure Cosmos DB. Make sure that you're always using the latest SDK. Evergreen your software on a regular schedule or even every time you touch the software. This is an easy way to make sure that you're using the libraries with the latest and most stable network features. Also make sure you enable SDK logging. One note here, logging can be expensive performance-wise, so only do regular logging of events that don't happen frequently. And make sure that you can use configuration to enable more logging in the event that you need to do some analysis of an issue. You can turn on log metrics in your Cosmos DB instance in the portal, which can help you determine server-side versus client-side issues. Your code can log the SQL query metrics that come back from the Cosmos DB SDK calls, as well as the diagnostic strings that are returned. Again, have some way to toggle your code logging off for regular production and on when you're performing issue analysis. Having the log metrics option turned on in the portal, you can check the portal metrics to determine whether an issue is a client-side issue, as in it's being caused by the client application, or it's a service issue, meaning it's caused by the Cosmos DB service. A common example is if you find the portal metrics show a lot of 429 errors, which means requests too large. This occurs when the request unit settings in Cosmos DB are not sufficient. In other words, requests are flooding the service, and your service's request units per second might have to be adjusted. This is a specific service issue having to do with throughput. If it's a client-side issue, you might not even see portal metrics for the Cosmos DB instance, since that's not where the error is occurring. Perhaps your application has logged the issue, and the request is not arriving at Cosmos DB at all. The Cosmos DB SDK has built-in retry logic if any request fails. Retry logic repeats the request on failure until a set number of attempts have occurred or a certain time has elapsed when the logic gives up. If you keep up with evergreening and are always running the latest Cosmos DB SDK, you'll always be using the latest retry logic. Note that from your application's point of view, retry logic is opaque. If there is an I/O failure during a request, and the internal retry logic of the SDK retry is successful, your application will get a success response from the library, and so your logic will never know there was a failure. Your application will only receive a fail result from the library if retry was unsuccessful. This automatically makes your applications built with the Cosmos DB SDK resilient to transient network errors when talking to the database. Retry logic is a must for any distributed cloud service. It's important that you know as a developer that the SDK has this retry logic, so that you don't try to implement your own logic or some other third-party logic on top of the SDK's logic. SDKs for many other Azure services contain retry logic, which may work differently than Cosmos DB retry logic. As a developer, always do your research to know what retry logic is in place for the libraries you're using. You should know some basic error status codes when analyzing issues arising in your applications that use Cosmos DB. These are not Cosmos DB specific, but are general status codes that can occur in any communication between client and server. 400 bad request. This can mean many things, so you should consult the error message. It generally means that the client sent a request the server doesn't consider valid. For instance, if a request comes into your application's underlying API to store a record to Cosmos DB, but your application logic has a rule that one of the fields of the record violates, your application may return a 400 error. 408 request timed out is an error sent by the server when a network connection has been idle too long. It could indicate that the client's leaving connections open, or that the server is not responding in a prompt enough manner. 410 gone indicates that the resource, such as Cosmos DB, that's the target of the request, no longer exists. It usually indicates a resource has been retired and removed from service. 429 too many requests is an error code you may see from Cosmos DB when there are many requests coming in a short amount of time. This means the service is overrun and cannot process all the requests. The solution here is usually either to temporarily slow down the number of requests or configure the database to be able to handle more requests. And 503 service unavailable means the service cannot process your request at the current time. This might be because the service is too busy, or it could be down for maintenance. Your applications should be able to handle these and other error codes that Cosmos DB returns. Review Cosmos DB documentation for possible error codes. Finally, note that the first number of these error codes has special meaning. Error codes starting with 4 are client-side errors that the client might correct by adjusting the request. Error codes that start with a 5, on the other hand, are server-side, indicating there's nothing the client can do about the error, the server needs to be corrected. This next best practice for troubleshooting is specific to Azure virtual machines. If your application that uses Cosmos DB is installed on a virtual machine that doesn't have a public IP address, then the number of connections of Cosmos DB will be limited by what are called Source Network Address Translation ports, or SNAT ports, which allow virtual machines on a private IP to communicate with public resources. You can experience SNAT port exhaustion, where Cosmos DB starts to throttle connections, drop connections, or even return request timeouts because of a limited number of available ports. Now you can fix this by adding your Azure Cosmos DB instance to the same virtual network subnet as your virtual server. Then enable service endpoints in the firewall settings of Cosmos DB and add the subnet where your virtual network resides to the access control list. Another fix is to simply assign a public IP address to your virtual machine, and then SNAT ports will not be used. Of course, this may be less than ideal for other security reasons. Your application code can also log diagnostic information that comes from requests to the SDK. In version 2 of the SDK, this is a diagnostic string that you need to parse. But in version 3, the diagnostics property is changed to a proper object, and you can read its properties. This diagnostics detail gives you information about the request made by the SDK and the response, including timings. If you log this information, then it can give you clues as to whether your Cosmos DB requests are experiencing latency. If you check the logs and do see that there's a high latency on calls to the database, there are a few reasons why this could be. Check the network between your application and database to see if it's experiencing high traffic. Also check that your application and database are in the same geographic region. It's always a good idea to have your application and database in the same region to avoid the latency of communications between the two traveling a longer network path. And finally, as long as you have metrics logging on your Cosmos DB instance, you can check the resulting query metrics, which will contain potentially useful information about the queries being made against your Cosmos DB database. Each query should result in a log entry which can tell you things such as how much time the backend takes to complete versus the client. You can use this information to gain insight into your individual queries and perhaps make them more efficient. For example, perhaps you see that your application performs a group of several writes to the database, and each one incurs some time at the server. Perhaps you could batch those queries at the client and send only one query that batch inserts all the data, thus incurring less time at the server. In this video, we're going to discuss some network issues that can occur when you're using the Java SDK to access Cosmos DB. Networking issues can have many different causes, but knowing these common causes should help you to troubleshoot. CPU usage is an indicator of load. If your application is overloaded, its network response will be degraded. So make sure the CPU usage on your application's host is not running any higher than 50%. And if it is, consider distributing your load to different hosts. Another tip is to minimize latency between your application and backing Azure Cosmos DB account by ensuring that they're running in the same region. It's bad practice to have an application and its database running in different regions, since you incur latency every time they talk to one another, which is often for most applications. You need to watch for connection throttling. There are Linux systems that have connection limitations. Be aware of any connection limitations of your host system. Also be aware that if you're running your application in a virtual machine that doesn't have a public IP address, you're also limited by the number of ports available. This is true whether you're using Source Network Address Translation, or SNAT, or Port Address Translation, or PAT, to communicate outside your virtual machine. Ensure you're not suffering port exhaustion. The Java SDK for Cosmos DB has a connection policy configuration that allows you to define the number of connections allowed. You could run into troubles if you're using an HTTP proxy and this number is greater than the number of connections that your HTTP proxy supports. Make sure your HTTP proxy connection count and the connections allowed by your SDK match up. Your application may get request rate too large errors. This happens when your request rate exceeds the provisioned throughput on Cosmos DB. Your application should be resilient to these errors by performing a backoff retry using the interval that the server returns, and you can get this interval by calling the getRetry after n milliseconds method. If there are too many of these errors, you should consider raising the throughput of your database in Cosmos DB. When in test, it's a good idea to test with expected production request rates to see if they hit the threshold when you start to get request rate too large errors. This will let you know how you should configure production for your expected request rates. You should log any network errors, since the error responses will give you useful details for debugging any network-related issues in production. The only note here is that you should be able to turn debug level logs on and off in production, so you can avoid swamping the server with log messages during regular functioning. Azure Cosmos DB Java SDK version 4 uses a log facade called SLF4J, which you should take advantage of to log in your applications. This facade supports some popular logging frameworks under the hood, such as Log4j, a Java-based logging framework for Apache, and Logback, which is considered a successor to Log4j. Finally, when troubleshooting network issues, you can look at the number of network connections. If you're running your application on a Linux host, you can run the netstat-nap command. Or if you're hosting in Windows, run netstat-abn to get a list of connections on the host. Filter that list to the Cosmos DB connections and look at the connections to Cosmos DB marked established. If there are more than the connection pool size for your host, then you have too many connections occur. Also, if you see many connections in the close_wait state, it can mean you're opening and closing connections too frequently. Keep in mind when you are actually troubleshooting that this is only a subset of what can go wrong in a network. But by using a combination of these tools, you should be able to solve a lot of the more common network issues when it comes to the Java SDK. So in this course, we've examined basic management tasks for non-relational data. We did this by deploying non-relational data using Azure Portal, Resource Manager templates, PowerShell, and CLI, Cosmos DB firewall, authentication, and security, using Cosmos Explorer, geo-replication with Cosmos DB, IP access control policy issues with Cosmos DB, and .NET and Java SDK issues with Cosmos DB. In our next course, we'll move on to examine Azure Analytics workloads.